Remember that every direct variation equation goes through the origin when you graph it. It goes through 0, 0. The constant of variation is the same as the slope, and the slope is attached to the x term. The number that's on x is the slope. The number that's on x is the constant of variation if it's direct variation. To graph them, graph 0, 0, and then use the slope. Use rise over run with that slope. So go up or down, and then go over left or right to get another dot. Continue doing that until you're out of room. Reverse directions, go the other way. Put as many dots on there as you can, and then put your ruler down on your farthest dot. Line your ruler up, check it with the farthest dot, the other side of that line, and then draw on your line. Your line has to go all the way through the grid that I give you, and you need arrows at both ends. So to draw this one, we already did, but I will do it again anyway. We know that it goes through 0, 0, so I put my dot there, and then we know that it has a slope of 2/3. So that's a rise of 2, so I go up 2, and then a run of 3 to the right. 1, 2, 3, put down a dot. Up 2, right 3. And then I'm out of room, so I'm going to go the other way. If I reverse directions, I just reverse everything. Instead of going up 2, I go down 2. Instead of going right 3, I go left 3, put a dot. Down 2, left 3, and then again I'm out of room. So, draw on your line, put your pencil on one end, bring your ruler up to your pencil, check it at the other end, make sure that it's lined up, draw your line with arrows on the ends. Okay, use a ruler, nice straight lines. We have 2 more to practice here, so let's go ahead and do that. This first one, y equals -3/4 x, is direct variation. It looks like y equals kx or y equals mx. So that's direct variation, which means I'm definitely going through 0, 0. Now the question is, which way is my line going to go? It is going to go down from left to right. Why? Yeah, because we have this negative sign here. Okay. Now you have a choice, and let me just go over this with you real quick. We have -3/4 sitting here. Is that the same as -3 divided by 4? Is that the same as 3 divided by -4? Yes, they're all the same. Okay? So when you are given a problem like this, the negative sign will look like it's written out front. Is that the same as -3 divided by -4? No, it's not. Why not? Yeah, when you divide 2 negatives, exactly, they make a positive. But we know that this is negative, so this actually would reduce down to a positive number, which is not what we have. This does not reduce down to a positive number. This does not reduce down to a positive number. This number is not positive, okay? So these 2 here are the same as this one, but this one here is not. So what I'm going to tell you, probably several times, is this negative sign goes to either the top or the bottom number, but never both. So you pick. Do you want to put it to the top number every time? Do you want to put it on the bottom number every time? Doesn't matter to me, okay? I like to put it on the top number every time. I like to do rise first, up or down. And that way I'm always going to the right every single time that I'm drawing a graph. So I'm going to put that on the 3, which means I'm using this as my slope right here. -3 divided by 4. So that's a down 3, 1, 2, 3, and then a run of 4. Which way am I going? To the right. The negative sign was applied to the 3. I took out the negative sign as soon as I went down 3. Now I'm just going to the right 4. 1, 2, 3, 4. I would continue doing that, down 3, left 4, but I'm out of room. So instead I'm going to go back up here and reverse it. And actually, by reversing it, I'm using this slope right here. Up 3, 1, 2, 3, and then that -4 right there tells me to run to the left 4. So I go up 3 and then left 1, 2, 3, 4. That's all reversing it does. It changes the sign of the rise and the run. So instead of negative, it's now positive. Instead of positive, it's now negative. I'm out of room for more dots. So those are the only dots I can put on there, which is just fine. Draw on your line very carefully. check it with the other far dot, and then draw it on there, 2 arrows, and it's done. Before I move on to the next problem, we're going to take 3/10 of a second to decide if this is the correct direction for this line based on the slope that we were given. Yes, it is, because this is going down from left to right, and we have a negative slope right there. Okay, always check that. It literally takes 3/10 of a second to make sure that that's correct. Okay, graph y equals 2x. What should we do? Huh? Okay, it is y equals kx. There's not some stuff hanging out over here. So this is direct variation, which means this is going to go through the origin. So I put that dot on there. Now what do I do? Is it right 2, up 1? Is it run over rise? What should I do to this 2? Put it over 1 so that I can see that it's rise over run. Okay? Now it is rise first. That's a 2 on top, so I'm going which way? Up 2, and then to the right 1, and I put a dot. Up 2, right 1, up 2, right 1. And then reverse it. Go back to the origin, and instead of going up 2, right 1, go down 2, left 1, down 2, left 1, down 2, left 1. It gives me a really nice looking line with lots of dots for me to make sure that I'm going through correctly. Line up my ruler, check it, looks good, so I draw the line, and I'm done. One thing that's worth mentioning here is, why do we graph? Pretty sure I mentioned it at one point this year. Why do we graph? A visual of what? Of what? The data points that you would get if you made a table. That's right. So basically this line right here represents all of the ordered pairs that make this equation true. This line represents all of the ordered pairs that make this equation true. Would this ordered pair right here work for the equation? No. Would this one work? No. How about that one right there? What about this one that's almost on that line? No. Only the ordered pairs that are directly on this line make the equation true. Like, for example, this one right here. That would be negative 4, comma 3. Negative 4 goes in there, and I get positive 3 equals 3. Makes a true equation. Same thing over here. This dot right here would be 3, comma 6. So if I plug 3 in here, I have 6 equals 2 times 3. Is that true? Yeah. So each one of these ordered pairs, there's an infinite number of ordered pairs on this line, but every single one of them works for this equation. None of these over here work. None of these over here work. If an equation can be written in the form y equals kx, the form we've been using so far in this section, then it represents direct variation. If you can't make it look like this, then it does not represent direct variation, which means it probably doesn't go through the origin. Okay? So, do the following equations represent direct variation? If they do, tell me what the constant of variation is. So, does this look like y equals kx? The answer is no, because of one big problem. The 7 right here, it's not y equals, you got 7y equals. So what should I do to make it y equals? Divide everything by 7, yeah. If I divide both sides by 7, then I get y equals 2/7 x. Now, is that direct variation? Yes. So my answer here is going to be yes. Do the following equations represent direct variation? Yes, this one does. And then it says, if it does, find the constant of variation. What's the constant of variation here? 2/7. So I'm just going to write k equals 2/7. These guys here are my answer. So basically solve for y and then decide if it's direct variation or not. How about the second one, 3y plus 4x equals 8? Doesn't look like it, but let's make sure. What should I do? Yeah, we were trying to solve for y, so we got to subtract 4x from both sides. This is good practice. We're going to be doing a lot of this in this chapter. 3y equals negative 4x plus 8. Now what? We don't have y equals yet. We have 3y equals. Divide by 3. So I'm going to divide this by 3. And the way that I want you guys to start writing this is to divide each individual term like that. Don't draw the big bar across. Draw each individual term. There's a good reason for that, which we'll learn in the next section. That gives me just y here equals negative 4/3 x, and then 8/3 doesn't reduce, so I'll just write plus 8/3. You're going to wind up with fractions every now and then on these types of problems. It's not that big a deal, okay? Don't forget what it is that you're working with. This is a slope here. Rise over run. We want to see that fraction. So, is this direct variation? No, why not? Yeah, it's not y equals kx. It's not y equals just some number times x. We got this extra stuff hanging off to the side here, and we don't know what that is, but that's not direct variation. So the answer here is no. And because it's not, we don't have to find the constant of variation. We don't have a k here. It's not even direct variation. Okay, the third one, what should we do? Yeah, we want to get y by itself still. So we're going to subtract 4x from both sides. And we get 5y equals negative 4x. Now what? Divide everything by 5. So divide this side by 5, divide this side by 5, and we get y equals negative 4/5 x. Is this direct variation? Yes. So I have to say yes. And then I have to say, what is the constant of variation? Yeah, negative 4/5, that number right there. So I'm going to write k equals negative 4/5. And of course we know that that is also the slope. But since they asked for constant of variation, I'm writing k equals, not m equals. How about the last one? Is that direct variation? The only way to know for sure is if we solve for y. So I want to solve that thing for y. Divide both sides by 6. Because this time the y is over here. I got to get y by itself over here. So divide this by 6. Divide this by 6. Do I know how to handle 3/4 divided by 6? Too much fraction? You don't want to get your fraction on a Monday morning? Oh, come on. It's not that big a deal. I actually prefer to do something a little bit different here. If you remember back in August, we learned that we can divide, but we could also multiply by the reciprocal, and the reciprocal of 6 is 1/6. The reason I'm doing that is because now I can easily take care of that problem on the left side. I'm left with y on the right, and on the left, what do I get? What? 3/24. When you multiply fractions, you multiply across. And then, what do we do? Okay, so reduce your fractions if they can. Does this fraction reduce? Does 3 go into 24? Yeah, how many times? 8 times. So this reduces down to 1/8 x equals y. Is that direct variation? Yes, it is. It's direct variation because we don't have a bunch of stuff hanging off to the side. It's just y equals kx. It's written backwards. I could write it forwards if I wanted to. Either way, it's direct variation. So I write yes, and k equals what? 1/8. Going back to what we did in the first place, we had 3/4 x equals 6y, and we want to divide everything by 6. We can do that. In order to do that, we have to put the 6 over 1, and then leave it, change it, flip it. Right? You guys remember that? Okay. If you leave it, change it, flip it, then you wind up with 1/6 times 3/4 x equals y, which is exactly what we had over here. So all I did was save a step by doing it this way. So you do have options in math. Try to remember all of your options so you can pick the one that saves you time. You're going to see lots of problems like this. Suppose y varies directly as x, and y equals 72 and x equals 8. If you see this, suppose y varies directly as x, and then they tell you that y is something when x is something. You have to solve these problems the same way every time. Because they said varies directly, that means that this equation that you're looking for is a direct variation equation. And my direct variation equation is what? Y equals kx, yeah. So as soon as I see this phrase right here, I know that I need to work with y equals kx. Now, they tell me that y is 72 when x is 8. That's like an ordered pair. That's like 8, 72. And anytime I have an ordered pair with an equation, I can plug that ordered pair in. So that's what I'm going to do. I'm going to take that 8 and plug it in for x. I'm going to take that 72 and plug it in for y. So I have 72 equals k times 8. What this lets me do is it lets me solve for k. As soon as I solve for k, I know what the constant of variation is. And because I know what the constant of variation is, I can write the actual equation, not the general equation, y equals kx. So that's what we're going to do. Solve for k. What should I do? Divide both sides by 8. So I wind up with k equals, what's 72 divided by 8? 9. So step 1, it says write a direct variation equation that relates x and y. We can now, because now we know what k is. Our direct variation equation is y equals kx, but k is 9. So y equals 9x is my equation. So now that we know the equation, we can use the direct variation equation to find y when x is 3. So they're saying x is 3 now. What's y got to be? So I go y equals 9 times 3, which is, what's 9 times 3? 27. That's your answer. When x is 3, y has to be 27 because of my equation. And then step 3, or part 3, use the direct variation equation again, but this time find x when y is 45. So what am I going to do? Plug 45 in for y this time. So I use y equals 9x, but y is 45 this time. 45 equals 9x. So I want to solve for x here. Divide both sides by 9, and I get 5 equals x, or x equals 5. There you go. Okay? So all of these problems are solved exactly the same way. As soon as you see this varies directly as x thing, then you know that you need to use y equals kx. They're going to give you two pieces of information to plug in to y equals kx. So you do it, you solve for k, find out what it is, and then you write your equation. From there, you can answer any question that they throw at you. Whether they ask you to find y or they ask you to find x. And it doesn't matter what the number is. You can do it from there. Y varies directly as x. Then they tell you y is 36 when x is 9. So what should I do? I should write y equals kx. And then substitute. So I'm going to write 36 equals times 9. Now I'm going to, why am I dividing by 9? Solve for k. So we divide both sides by 9, and we get k equals, okay, now what do I do? There you go. Write the equation, y equals 4x. They're going to be looking for that as an answer. There's like two parts to this problem. The equation itself, and then the answer that you get when you do this. Okay? I have to see the equation, and then I have to see the answer. All right, use the direct variation equation that you just found to find y when x is 3. What do? Substitute y equals 4 times 3. So we get y equals, easy. Last one. Use the direct variation equation to find x when y is 48. What do? Substitute. So I write that. Oh. Right, y is 48. So I write 48 equals. Okay. Now what? Divide both sides by 4 and I get. There you go. As you read this problem, it says the distance a jet travels varies directly as the number of hours it flies. As soon as I read that sentence and I see this varies directly thing, something should pop into my mind immediately. What should pop into my mind? What's that? The equation, y equals kx, yeah. So we're going to be working with y equals kx on this problem too, even though it's a story problem. Then they tell me a jet traveled 3,420 miles in 6 hours. Is that pretty fast? Seems like it. Seems pretty fast. Okay, so it says write a direct variation equation for this situation. Well, we know we're going to be using y equals kx, and they gave me some information here. We need to determine which number goes with which letter. So x is always the independent variable. Y is always the dependent variable. So which one is which here? Is hours x or is miles x? Anyone? Anyone? Bueller? Nothing? Come on. Which one makes the other change? The amount of time goes by, so the number of miles the jet has flown has increased, or the number of miles that a jet flew tells me how much time went by. The other way around. It is how much time goes by tells me how far the jet flew. Okay? Time is the independent variable here. So we're going to call hours x. If you need to write that down to keep it straight, then write it down. X equals number of hours. And y equals number of miles flown. Now that I know that, I can use my direct variation equation, y equals kx, and substitute stuff in. So what will I write? What do I know for y? 3,420 miles equals k times 6 hours. And now what do? Divide both sides by 6. So what is 3,420 divided by 6? 1,270? Oh, 570. What would the units on that be, just out of curiosity? What were the units here? Miles. What were the units here? Hours. That's miles per hour, yeah. You just came up with 570 miles per hour equals k. Is that pretty fast now? Yeah, remember rate of change is the same as slope. And when we write this equation, y equals 570x, the 570 is our slope. Our rate of change is like a speed. The speed of the plane was 570 miles per hour. So for every hour that it flies, how far does the plane go? 570 miles. Okay, now it says graph the equation. How am I going to graph this? How do I make a graph when I'm given a grid like this? What? I don't remember. It's been a long time. So yeah, we got to put our axes on here. Where should I put my axes? Dead center? Why not? Because why? There's no negative time. And there's no negative miles. Okay? So I can actually put my axes here. Now I got to label my axes. What goes on the x-axis? Hours. X variable was hours, which makes miles on the y-axis. Now this is a direct variation equation, so how do I graph it? Okay, rise over run, yes. But where do I start? At the origin. So I know I have a dot right there. Need a scale. So for every 1 hour, I go 570 miles. Right? So can I go by ones for hours here? Okay. Can I go by ones for miles here? Definitely not. 500, go by 570s? Go by 200s? 100s? Go by 500s? 700s? Whatever you want. Let's go by 500. So this will be 5, 1,000, 5, 2,000, 3,000, 4,000, and so on. So now we just got to put some dots down. When we have 1 hour gone, or actually we can use our slope. Maybe. So to use the slope, I got to go up 570 from here, 500 right there, 70 right there, over 1. Up 570, over 1. Up 570, over 1. Up 570, over 1. Up 570, over 1. See how I did that using the slope? Okay. I'm kind of guessing on where that 570 is here, but I'm pretty close. Got a bunch of dots on there. Can I draw a line? All right, so let's draw that line. Goes through the origin. That plane could keep flying if it never ran out of fuel. So we're putting an arrow at the one end, but not on the other. So there's your graph. And number 3, estimate how long it would take the plane to fly from here to Chicago. And then I'm telling you that Grable is about 1,200 miles from Chicago. So what should I do? Plug in 1,200 where? For y, that's right. So my equation is y equals 570x, but y represents miles, not x. So I'm putting 1,200 in for y equals 570 times x. So solve for x, what do we get? What do we do? Divide by 570. .1 sausages. Bacon, miles per hour? Hours. X is hours. So our units here are 2.1 hours. So it only takes 2.1 hours to fly from Chicago to Grable. Okay, the last thing we have to do in this section very quickly, because it's kind of easy. For the data in the table, does y vary directly with x? If it does, write an equation for the direct variation, okay? To do this, all you need to do is divide each one of these, y over x. 6 over 4, 12 over 8, 15 over 10. I'm just taking the y coordinate and dividing it by the x coordinate. If I get equal fractions each time, then it's direct variation. If I don't, then it's not. So 6/4 reduces down to 3 halves. 12/8 reduces down to 3 halves. And 15/10 reduces down to 3 halves. So I wound up with the same fraction every time, which means that yes, this is direct variation. And the equation is staring you in the face. Because it's direct variation, it's y equals kx. The k is that number that you reduce down to every time. So 3 halves. Y equals 3 halves x is the answer. So you say yes, y equals 3 halves x. Let's take a look at the second one. I need to do 3.2 divided by negative 2. I need to do 2.4 divided by 1. I need to do 1.6 divided by 4. On your calculator, go ahead and enter those in. Do I get the same number each time? This one's 2.4. This one's negative something, 1.6. This one's like 0.4. Do I get the same number each time? Nope. So this is not direct variation. For the last one, do the same thing. 2.25 divided by negative 3, negative 0.75 divided by 1, and then negative 3 divided by 4. This one is just negative 0.75. This one is negative 0.75. If I enter that in my calculator, I get negative 0.75. So is this one direct variation? Yes. And what is the equation? Negative 0.75 x. Negative 3/4 x. That does it for the section.